Homework solution 2.11, the voltage source is known to be 340 at angle 0 degrees volts. Find the real and reactive power delivered by the voltage source. Is the voltage source absorbing or delivering real power? And is the voltage source absorbing or delivering VARs? So we're given this circuit source, circuit schematic here, with the only additional information being that supply is equal to 340 at angle 0 degrees volts. We're asked to find the real and reactive power delivered by the source, so that's just P of the source, Q of the source, and we want to know direction of power flow. So to solve this circuit, probably the easiest way to proceed is to find the Thevenin equivalent of all of these elements. Fortunately, they're already given to us in their impedance forms. We don't have any frequency information, so that's already given to us here. So we've got this total impedance is just going to be equal to 50 plus the parallel combination of 100 ohms with minus J100 ohms with 80 plus J60. So that parallel combination is going to be equal to minus J100 times 80 plus J60 over minus J100 plus 80 plus J60. So this here takes care of this parallel formulation, and then we add that to the series 50 ohms. Throw that in your handy dandy TI-89 and you get 150 minus J50 ohms for total circuit impedance. To determine P and Q, I'm going to go by just using S, and I'm going to use V star over Z star, which is just equal to V squared over the complex conjugate of the impedance. So I get 340, which is the voltage. What I've done is this. So I know that the voltage across those terminals is 340 volts. Square that. Divide that by the complex conjugate of that. To take the complex conjugate of a rectangular number, just invert the sign on the reactive portion of the impedance, 150 plus J150. And so then if you just write this, throw that in your calculator and put it in rectangular form, it will give you 693.6 minus J231.2. So this is the source is delivering 693.6 watts, and it is absorbing 231.2 VARs. It's delivering because the sign is positive. It's absorbing because the sign is negative here. Another way to know that it's absorbing VARs is that the circuit overall looks capacitive. Capacitors supply VARs, therefore the power supply has to be absorbing the VARs that are being supplied by the capacitive circuit.